Rotate list. Give the head of a linked list rotate list to right by k places. We have an example here. We want to rotate by 2, so we rotate 4, 5 to the front. And then we have this one, we rotate 4 times, so we do the rotate 4 times to get this one. For this one, I'm gonna basically use iterative approach. Have a slow fast pointer, move fast pointer first, and then move slow and fast both at the same time. And then when fast reach the end, we are at the red position. So let's start coding. I will first create a few nodes. I will have a slow, which point to the head first, and then I will have a fast, point to the head first also. I will also have a node called curve. I will point to the head first. I will use that curve to help me count the linked list length. So I will have an integer called length equal to 0. Well, curve not equal to 0, not equal to now, then I will say curve equal curve dot next length plus. The reason why I count the length of the linked list is because when k is greater than the length of the linked list, we actually didn't need to do all the rotate, because the real rotates we need to do are k modular by the length. Because if the length is equal to the k, then we do a 100% rotate. After that, we still have the same linked list. So to get a true rotate, we need is by k modular by length. After that, we get the length, so we can have an integer called rotate. It will be the k modular by the length. And we'll check if rotate equal to 0, then I will just return the original linked list. Otherwise, I will first move fast pointer. So for int I equal 0, I less than rotate I plus plus. Fast equal fast dot next. And then after that, I will move both slow and fast at the same time. So well fast next not equal to now. So as long as fast is not at the last node, I want to keep the iteration. I will say slow equals slow dot next. Fast equals fast dot next. And then at the end of while loop, we are at the right place. Next, we can change the pointers. First, we need to record the new head. So this node, new head. The new head will be the next node to the slow node. So when we at the end, slow will be at 3, fast at 5. 4 will be our new linked list node. Linked list, the head of our new linked list. So we say new head equal slow dot next. Next, we can say slow dot next equal to now. So that means 3 is the new tail. Next, we can connect the 5 to the 1. So fast dot next equal to head, the original head. and then at the end we can just return new head. And lastly, let's do some edge case check. So if k equal to 0, then we don't need to rotate. Or if head equal to null, that means empty linked list. So or the head.next equal to null, linked list with only one node. For all those cases, we can just return the original linked list. For the time complexity, will be O of n, because even though we have 3 loop, which is 3n, we drop constant, so it will become n at the end. The space complexity will be O of 1, because we just create a few nodes. We don't create any data structure, so it will use constant space, so it's O of 1. Next, we can test the code out. Looks like we passed the test.